All right, question 11. Integrate x squared minus x over x with respect to x from -1 to 1. This is easy because you see that we could divide x squared minus x over x to have simple function to integrate. So x squared over x will be x minus x over x is 1. And we integrate from -1 to 1 with respect to x. The integration of x, you increase the power by 1 to be x squared over 2 minus, you integrate 1 if of course will be x, and our bound will be from -1 to 1. So we're gonna substitute for f of 1, f capital of 1. Capital means the function after integration, minus f of -1. So 1 will be 1 square over 2 is a half, minus x is 1, okay, minus. Substitute for -1, -1 square is a half, 1 over 2 is a half, minus. Negative times negative is positive. Yes, again, -1 times negative is positive 1. Then a half minus 1, and negative, distribute negative to be negative a half, and negative times 1 is -1. Cancel out a half with a half. Then it will be -1 and -1 is -2. The answer will be A. And now I have question 12. Question 12. The table above gives selected values of the differentiable function f. Which of the following intervals must there be a number c such that f dash of c equals 2? To solve that, what I want you to do is to go over a very quick work. If you find derivative between 0 and 4, it will be 0 minus 8 over 4 minus 0. So the derivative 0 minus 8 is -4 over 4 is -1. And here. And if you do the derivative from 4 to 8, between here, so it will be 2 minus 0 over 4, 8 minus 4. 2 minus 0 is 2, and 8 minus 4 is 4. 2 over 4 is a half. And then if we do the integration from, the derivative from 8 to 12, it will be 10 minus 2 f of 12 minus f of 8. That's f of 12 minus f of 8 over 12 minus 8. F of 12 is 10. F of 8 is 2 over 12 minus 8. Evaluate that to be 8 over 12 minus 8 is 4. 8 over 4 is 2. So over here is 2. And the last one, if you evaluated, will be 1 minus 10 is -9 over 4. Doesn't match. So the only period or intervals that could have f dash of c equals 2, which is from 8 to 12, the answer is C.